Let's take a look at our Jamboard. We're going to use equations to complete the tables and make graphs. And then we're going to decide whether the equations represent a linear or a nonlinear function. So let's look at the equations that we have in the lesson. Let's look at number 2. Okay, let's consider what type of equation will produce linear graphs. After we do these two problems, number 2 and 3 on page 74, we'll be able to tell what's a linear function and what's not a linear function. Number 2, up top on page 74, says use the equation y equals 2x plus 1 to complete the table of values. Then use the table of values to make a graph. Use the equation y equals 2x plus 1. It says, does the equation y equals 2x plus 1 represent a linear function? So again, I'm looking at my problem, and the first thing I'm going to do is I'm going to tear that problem up. I'm going to ask myself, what is this problem about? This problem is about this equation right here. Okay? Then I'm going to ask myself, what is this problem asking for? It says use, that's my verb, use the table of values to make, okay, that's my second part, make a graph. And then it also asks, does the equation represent a linear function? And so I'm going to highlight that. So I'm doing 3 things with this problem. The first thing I'm going to do is I'm going to use the table to make a graph. So in order to make the table, I have to use what I know in order to complete the table values. Okay, and what I do know is this equation right here. So that's what I'm going to do. I'm going to plug -2, my x, into this equation right here and add 1 in order to get y. So -2x times 2 plus 1 is going to give me my answer for y. The first thing I do in PEMDAS, and I'm going to write that over here, PEMDAS. My P tells me I'm going to multiply, add, divide, or subtract anything that's in parentheses. My E tells me I'm going to do the order of operation of exponents next. After I do exponents in my order of operations, I can multiply and divide from left to right, and then I can add and subtract last in my order of operations. So in this equation specifically, I'm going to multiply first. I'm going to multiply y equals 2 times -2 plus 1. I'm going to multiply first, so that makes 2 times -2, -4. I'm going to bring down what's left. That gives me plus 1, and I'm going to just rewrite my equation with what I simplified already. Now I'm going to add my -4 and 1. So that gives me -3. So my answer for the first problem is -3. Now let's try the next one. I'm going to write my equation, y equals 2x plus 1. Then I'm going to plug my -1 into this equation. That problem gives me 2 times -1. Remember, I'm getting this from my x column over here, plus 1. Then I'm going to simplify by doing my PEMDAS, my order of operations. I start with multiplication and division first. So the only thing I see in my problem is I'm multiplying. So 2 times -1 gives me 2. Then my order of operations tells me that I need to add and subtract. So I'm going to add my -2 to 1. And that gives me -1. I do the same for these problems. All I'm doing is I'm plugging my x into my equation. 0 will give me 1. If I plug my 1 in x, I will get 3 for y. Plug in 2 for x. My answer for y is 5. Now I'm going to plot my points. My x is -2. My y is -3. Coordinate is -1, -1. Remember, my x coordinate is the first coordinate. My y is the second coordinate. So my x is 0 and y. That means my x is going to be on this axis and my y is at 1. My next plot is 1, 3. And last, my 2, 5. Notice that when I plot my points, I have a linear function. It is a straight line if you connect the dots all the way through. This 2x plus 1, y equals 2x plus 1, is therefore a linear function. The graph is a straight line, so it is a linear function. Let's do the same for number 3 on page 74. We're going to plot our y's by filling it into this equation here. It says use the equation y equals x cubed to complete the table. Then use the values from the table to make a graph. Does the equation y equal x cubed represent a linear function? Well, let's see. First thing I'm going to do is I'm going to look at my problem and see what this problem is about. And it looks like this problem is about y equals x plus 3. Now I'm going to ask myself, what is this problem looking for? This problem is telling me to complete the table. That's my verb, complete. Another verb is use. It says use the values to make a graph. So I'm going to complete this table, make my graph, and then I'm going to answer this question. Does the equation y equals x cubed represent a linear function? So we're going to see whether it's a linear function or a nonlinear function. Let's start with the basics. What do we know? I know that I'm going to complete my table by using that equation. Y equals x cubed. Cube -2, it's going to give me -8. If my x is -1 and I cube it, meaning I multiply it 3 times, my cube is going to be 1, -1. Cubing 0 will give me 0, cubing 1 will give me 1, and cubing 2 will give me 8. Now I'm going to plot my coordinates. My first plot is -2, -8, -1, -1, 0, 0. That's interesting. By my third plot, it looks like I'm curving. 1, 1. Last 2, 8. Notice how my lines start here, straight, and then we start to curve. And this is what exponents do, whether square, cube, to the 4th, 5th, 6th, 7th power. Okay? Notice how my line is not straight. This is not a linear function. Notice how our equations from both pages show that y equals some form of variable x. One equation includes a constant and the other does not. Here I have a constant, my 2, whatever my constant is. Here I have a constant as well, but with one equation it includes a coefficient. Okay, so there's a number in front of whatever this problem is. My coefficient in this case is 1, and I have my 2 here. Those are my coefficients. One equation includes an exponent. This one does not. This equation has an exponent. So notice the differences between the two of them. When I have my coefficients, my line is going to be straight. When I have exponents, my line is not a line. It's a nonlinear function. Okay? How are the graphs of the two equations similar? Okay, both of these graphs increase in y as my x increases. Okay, the bigger my numbers, the bigger my output. The bigger my numbers, it goes from -2 to 2, the bigger my output. Okay, so one graph has a constant rate increase. Okay, this is this graph right here. It's constant. It's straight. Okay, it's going in one direction at a similar rate. The rate stays the same. One graph does not. The other increases at a varying rate. That means that we curve, it varies and it changes depending on what my output is. That means it's a curve.